I feel like every time I talk about image formats, people get mad at me. But you know what? I don't care because it's an important topic, and serving the best image assets to your users is an important thing for us to do and get right. And as much as I'm skeptical of certain new image formats and supportive of ones that y'all don't necessarily love, there is one thing I think we can all agree on. PNG is awesome, but slightly overused, especially when you consider how many features it's missing, because it's a pretty old codec. There just aren't many things you can do with PNG, and it's behind in a lot of ways. It can't be animated, the compression is weak at best, and most importantly, no HDR support in the codec. What? It's 2025. All of our phones are HDR now. How are PNGs not? Well, they weren't. Until now, because PNG is back. For the first time in a long time, the PNG spec has actually been updated and improved, and the future is really bright. I am so excited to talk all about the cool new things PNG is doing and how the web might actually evolve with images now. It's taken long enough. Like, how insane is it that CSS had HDR support before PNGs did? Like, what? Yeah, we got a lot to cover here, but someone's got to cover the bandwidth of all these uncompressed images. So quick word from today's sponsor, and then we'll dive right in. I don't know about y'all, but I've been spending way more time waiting on builds lately because we're shipping way more code. AI's made it easier than ever to file a PR, especially with all these fancy background agents. But if you're waiting 5 to 10 minutes for those builds, not only are you stuck waiting all the time, you're also spending a bunch of money on those minutes on GitHub Actions, which seem cheap until you're shipping enough. Unless you're using today's sponsor, Blacksmith. These guys are going to make your builds way faster and, more importantly, way cheaper, so you'll be less scared to have all these PRs flying in. It's literally a one line of code change in your GitHub YAML file for your action in order to get started, and you'll immediately start saving money and time on those builds, up to 75% cost reductions. Tons of companies are already making the move, like Mintlify, Clerk, and more, and there's a reason. The actual builds themselves are way faster because they're using gaming CPUs from like gaming PCs, because the single core speeds on them tend to be way better. They also are doing a ton of fun stuff for caching. They give you twice as much cache data as you get on GitHub Actions. They give you 4 times faster cache downloads by co-locating the storage instead of using some old hard drives in a different server rack somewhere else in the building. And most importantly, Docker builds are way faster because they're caching the individual layers on NVMe drives, which is just insane. 40 times speed improvements for a lot of those builds. They charge half as much per minute. They are twice as fast usually, which means 75% off. That's pretty hard to beat. On top of that, you get 3,000 minutes a month for free. So why not give it a shot? Check them out today at soydev.link/blacksmith. It's probably best to start with the background so we understand how we got here and the 20 years it took for us to get here. The last PNG spec was released over 20 years ago. Technology's advanced a lot since then. We're talking 3.5 years before the first iPhone. In fact, technological advancement is what resurrected PNG. The W3C Timed Text Working Group, think subtitles, needed HDR support in PNG. A proposal was made, but a few experts decided we could do better. Momentum built, and additional parties became interested. Before we knew it, we had representation from, in alphabetical order, Adobe, Apple, BBC, Comcast, NBC Universal, Google, Movie Labs, and of course W3C, who maintains the spec. It's quite the dream team. With these two titans behind it, the image format is back with full momentum. Work has already begun on the next 2 PNG spec updates. That's really cool to see. Okay, now that we know why this happened, let's see what they actually changed. There's some really cool stuff here, and I think the many places that use PNG are important to know about as well. I can't not look at it. It's obviously not the best thing ever to read. You know it's good when it has more than 20 authors on it. Jesus Christ. Necessary, though. This is an important standard. They even got their representatives from Adobe in here, bunch of W3C experts, the usual. First important detail here is defining 2 internet media types, image/PNG and image/APNG, because they're finally mainlining and officially supporting animated PNGs. It took this long, but yeah, they're doing it. PNG provides a patent-free replacement for GIF. It could also replace many common uses of TIFF. Index color, grayscale, and true color images are all supported, plus an optional alpha channel. Sorry for covering that with my face. Sample depths range from 1 to 16 bits. It's lossless, portable, and well-compressed storage of static and now animated raster images. Fully streamable with a progressive display option. It's also robust, yada, yada, yada. PNG can store color spaces for improved color matching on heterogeneous platforms. Defines these 2 types. This is it's an official spec doc, so there's a lot to read through here. I could do it. It is honestly tempting. I might take the time to later because I'm a big nerd about these types of codecs and these types of encoding things. But I will spare you all that and read Program Max's summary here. PNG is back to its former glory after its progress stalled for over 2 decades. Did you know that the US Library of Congress, Library and Archives Canada, and the National Archive of Australia recommend PNG? It's important that we keep PNG current and competitive. After 20 years of stagnation, PNG is backed with renewed vigor. I actually think it's really good for standards committees and like archives of any form to default to PNG, because as much as I think that's not what you should serve your users, I really don't think that for the majority of the time, a user on your site should be getting a PNG. It's literally 100 times bigger than a lot of the alternatives for no perceivable like difference in quality. The problem with other formats that I support and love, like WebP, AVIF, and all these other things, is that they are some amount lossy. You can use them lossless some amount, but usually you're using them at like 95 to 99%, which means you end up re-encoding them as you pass them around. Or if you save an AVIF or WebP and then you throw it into your photo editor of choice, do some stuff to it, and then export it again as a PNG, throw that on the web, and then that gets re-encoded to AVIF, the quality of the source gets lower and lower every step of the pipeline, which is not great. So for preservation, these lossy formats aren't a good thing. But for distribution and giving better user experiences on your applications, these lossy formats are magical. They're life-saving. Products like PicThing are background removal for content creators tool that I built mostly for me and my team to use. This product literally wouldn't be possible without AVIF and WebP because it allows us to serve hundreds of images in kilobytes of data. And then when you want to save the image to use it, that's when we download the full quality PNG, but we don't until you're doing it. Otherwise, you would load like 400 megabytes of content whenever you open the dashboard, which would not be acceptable. As funny as it would be, not viable. Like, do you see how many images we are loading here? In each of these, even though they look great, if I hop into the network tab, we'll see any one of these is very small. These are cached. Can I see the size? Yeah, 8.3 kilobytes for one of these. Be cool if Firefox's dev tools weren't absolute fucking garbage. There we go. 8.3 kilobytes for almost all of these images. And if I take one of these and go to the original source, this image, you can't see because my face is covering it. I'll do that. Yeah, there we go. 3.83 megabytes. So it went from 8 kilobytes compressed and visually identical in the UI to 4 megabytes. And when you're loading hundreds of these on a page, that's not viable. We should not be using PNG for this. It would make no sense to use PNG for this. This is why it's important to have these other formats that you can use for these different things, because different use cases demand different requirements. I like that we have a variety of image types, even if people don't like that if they right-click and save, it's not going to be an image type that they want to use. Just make sure you provide ways to get to the source image for those who need them. Doing this right isn't as hard as people seem to think, but a better PNG means everyone gets to make progress, especially those who care about re-encoding and archiving images. Otherwise, we end up in the do I look like I know what a JPEG is world, because you resave it, re-encode it over and over again, and you end up in hell. Back to the article here, though, because this is really cool. After 20 years of stagnation, PNG is back with renewed vigor. So what's new? Proper HDR support. If you somehow don't know what HDR is yet, and you're on a modern-ish iPhone or Mac, I would highly recommend you go check out the most recent Digital Foundry video, the Death Stranding one. We don't encode our videos in HDR, so this will not look particularly good at all, coming from me, but if you have a high-end monitor or a system that actually knows what HDR is, the intro for this video that Digital Foundry just put out is within the best HDR demos I've ever seen in my life. A combination of the Death Stranding engine and the crazy work that teams put into making it so stunning, as well as Digital Foundry's very tasteful highlighting of the coolest parts here. There's a scene in this with an elevator here. It's right after the walking part here. This scene with the elevator on a proper HDR display is stunning. You can see all of the details in the woman's face in the shadow, which is dark, with a bright light that's almost blinding. That's what HDR is. It's high dynamic range. It means the darks can be darker, the lights can be lighter, and there's a wider range of how things can look. And it makes things look way better if they are encoded properly. HDR is how we get more out of our displays. It's how we make these much more realistic feeling images, but it also requires different encoding because we need a larger set of colors and a larger set of bright and dark ranges in order for this to work. And PNG just didn't support it. If you had a camera that could shoot HDR and you export a PNG, you just gave up the HDR entirely. Until now. This figure shows the colors that our eyes can see. The smaller inner triangle represents the color space of most images. The larger outer triangle represents the color that are typical with HDR images. It doesn't also show the like brightness and darkness benefits too, but one of the biggest deals with HDR is it almost always implies the brightest brights can be way brighter. The color range part's cool. I care more about the lights and dark side of it, but both are important. The new HDR support uses only 4 bytes, plus the usual PNG chunk overhead. Pretty cool. Chris Lilly, one of the PNG original co-authors and current technical director contributing to the new PNG work, wrote an excellent article explaining how this works. I'm a big nerd about this. I'm going to scroll through this. This is going to be fun for me. This is written for semi-normies. This will be really fun, actually. Let us define what we mean by a color. It's an objective, measured value describing the human visual perception of some object that is emitting light. Or for physical objects, it's illuminated by some light and reflecting some of that light to our eye. The measurement consists of 3 numbers, x, y, and z. 2 objects that have identical x, y, and z values will look exactly the same color to a normal human observer. And these are the x, y, and z values assigned here. It's common to convert this into chromatic values, x and y, where x is x plus y plus z, y is y over x plus y plus z. Cool. 2 objects with the same chromaticity values will look the same color, but one might be brighter or darker than the other. To reproduce a given color on a particular screen, we need to know the chromatices of the red, green, and blue primaries, and also the exact color of the white that results when those 3 are mixed together in equal proportions. ProPhoto, Rec 2020. Rec 2020 is a really common color encoding. Rec 709 is the standard cinema encoding. All these are different sets of color out of this huge range of what humans can see. We also need to know the relationship between the numbers we send to a screen and the amount of light generated. This is typically not a linear relationship. For example, if a monitor takes between 0 and 255, and we send a number in the middle, we would only get 21% of the full brightness, not 50%. This is the transfer function. So setting brightness is not as trivial as number go up, brightness goes up by the right percentage. Here we can see how these ranges are visualized and which ranges and values are and aren't allowed on different devices. So this monitor can't do P3 color gamut because I'm plugged in with my HDMI extension and the monitor on that side isn't HDR ready. But this is a really cool visualizer. Also, Juxtaposed has a video on color too, apparently. If you're not already watching Juxtaposed's channel, it's awesome. I actually did watch this video right when it dropped, and it was really good. If you haven't done it yet, you should. And you should also subscribe to Juxtapose. He's phenomenal. I love all of the stuff he has done. And you should also sub to me if you haven't yet. If you're this far into a video and you haven't subbed yet, come on, hit the button. It's free. You get the idea, though. Really cool sources. A ton of cool stuff going on in this world. An important piece here is that CICP allows for labeling of what color space is used for a given image. It doesn't say how to handle it. It just says which of the many different color spaces exist is being used for something. It was originally introduced for video by the Telecommunication Union so that they could broadcast different television, record in different ways and encode it in different ways and say, hey, here's the color standard that we used for this, so you could change it on your side too. CICP isn't just for video anymore. It's been adopted by still image and animation formats like AVIF and JPEG XL, and now PNG supports it too. CICP and PNG is actually fucking huge. It encodes the color space using just 4 numbers, each of which can be encoded in 1 byte. The actual meaning of them is in the spec. The color primaries are the first 2. It specifies the chromaticity of the red, white, green, and blue, thus defining the color gamut, and then the transfer characteristics for the interconverting between pixel values. That gives you everything you need to convert to most formats, which is dope. All of the things in this so far have been SDR, which is the normal dynamic range, so that white is just standard 6F. It's also the brightest color that can be displayed. Media white can be comfortably viewed over the whole screen. That's another thing, is when you're using proper HDR white, you want to be careful how much white is appearing, because it's blinding when you use the HDR white. I know some people, apparently Slack GIFs can be HDR, and people have been very annoying in certain Slack servers torturing people with HDR GIFs. As I was saying before, HDR means you can also do significantly brighter colors as well as darker colors than dark gray, which often represents black on SDR. Once you've seen proper HDR on a nice OLED, You realize black's a color again because almost everything else is just gray. BT2100 is the main HDR standard, which gives a significantly wider gamut than Display P3, but doesn't necessarily mean the content takes advantage. Yep, all correct statements. Yeah, 2020 is the downsampled SDR space used by most HD TVs. That's very, very common. I've encoded a lot of things in that. Hybrid log gamma HLG, which is HDR space for live broadcasts like sports, also used on iPhone clips. You ever seen on an iPhone when you're looking at a video, often on Instagram when they were doing HDR aggressively early on, you might notice that like your screens, it feels like your phone's brightness changed fundamentally when you open a certain video. That's because the videos on your phone are shot with that higher range of color. So the highlights from the sun coming through the window and the shadows in the like corner of the room can all be visible at the same time. And it looks insane. It's so cool. But you need a phone screen and processing and encoding that handles all of this. And now PNG does it. The way that they implemented it is optional. So if your browser or like viewing platform doesn't support the new like color space stuff, it just makes the image look a little washed out. That is pretty cool. If I understand this correctly, it means everything's backwards compat, which is huge. Great article, Chris, by the way. That was super, super cool. Links in the description if you want to check this stuff out, because this is a very detailed write-up. There's a lot to learn from. Oh shit, Chris is the father of SVG. That's really cool, actually. Good stuff. That's not the only thing that it's supported, though. They finally recognize APNGs as an official standard. I've had to deal with some shit with APNGs in the past. Certain Adobe software really likes it, and I've had things sent to me as APNG, and then nothing fucking supported it because it wasn't a real standard. Like, God, APNGs is such a rough... It was such a rough thing, so it wasn't official. Everyone disagreed on how they worked. Things like FFmpeg didn't support them because it wasn't a real enough standard. That's over. Support's been added to Firefox of the fake standard because it was a proposal by Mozilla. They pushed it pretty hard, but everyone else was hesitant. But now they are widely supported in the spec reflects reality by actually including it. That's a really nice change. APNG, you didn't know this about GIFs. They aren't really compressed. Each frame in a GIF isn't encoded as motion data. It's a full new image. You have a full frame for every frame in a GIF. So the longer the GIF is, each additional frame is a multiplicative increase in the size of it. It sucks. GIFs are very bad formats for animations. APNG, same deal, but for lossless frame-by-frame encoding, useful. I still think you should use WebP, WebM, or even AVIF nowadays. But if you want a lossless, small, encoded animation, because you want every single frame to be as accurate as possible, APNG is a great way to do that. And it supports transparency. GIF kind of supports transparency, but depending on the version you're using and the browser you're using, it's iffy how well it's supported. Regardless, APNG is very useful, especially for asset transfer stuff. Like if I'm working with an animator to make like an emote that's animated for my chat on Twitch, them sending me an APNG, even if it's huge, like 30, 40 megabytes for 2 seconds, that's actually really good because I can re-encode that to anything fully losslessly, which is nice. And they can send me a preview in the browser, even if it takes a while to load. Benefits and negatives, all of this. But APNG is a transfer format, in particular, archival format. Really, really useful as a simple lossless animation encoding. That said, lossless video is something you very, very rarely need. It's mostly a production tool. So I'm scared APNG becoming popular might end up being a bad thing because it's not the format most of us should be using. Most consumption should not be lossless formats. I will die on that hill. Be mad at me all you want. You're wrong. We shouldn't be loading 40 megs when we could be loading 40 kilobytes. That's just reality. And video compression's gotten so absurdly good that we should take advantage of those things when we can. Oh, finally Exif support. Holy shit. Oh God, I can't believe it went this long without it. It's silly, but I've often recommended to people who needed to anonymize an image so that you couldn't use the Exif data to figure out how it was taken, who took it, and all of that. I would often tell them, just go convert your JPEG to a PNG because it will drop all of that data. It's silly, but that was like a benefit of PNG because the spec was so old that these things just didn't matter at the time. But now, finally, a PNG can have information about the PNG in it. Crazy, absurd thing. This is nice to see. So this all sounds awesome, but what's actually supporting it? Thankfully, it seems to be relatively backward compatible, but I want more of what's using it so far. Many of the programs you use already support the new PNG spec. Chrome, Safari, Firefox, iOS/macOS, Photoshop, DaVinci Resolve, Avid Media Composer. Plus, you saw some broadcast companies in the list above. Behind the scenes, hardware and tooling are being updated to support the new PNG spec. The next time you see a news ticker scrolling, "Brave dog saves family," or the score banner updating as your team pulls out a clutch play, check if it's in HDR. That's cool. The idea of the ticker being able to be brighter or darker as needed because PNG supports it, that's really cool. Because a lot of those tickers and those other layers in broadcast tend to be based on PNG. Very cool to see. What's next? I know you all immediately wonder, better compression? We're already working on that, and parallel encoding and decoding too. Just like this update, we want to make sure we do it right. We expect the next PNG update, 4th edition, to be short. It will improve HDR and standard dynamic range SDR interoperability. While we work on that, we'll be researching compression updates for the PNG 5th edition. That is really cool. I'm super excited about this. This is an awesome change. I obviously, as a media person that does a lot of code stuff and spent a lot of their life working on media and encoding pipelines, I'm biased and think this is the coolest shit ever. This is the first new standard I've seen that's such an obvious, immediate, apparent win that everything should start adopting it and using it that is already on PNG at the very least. I am extra excited for better compression because that's my biggest issue with PNG, and it's why I don't recommend it for user-facing stuff unless you are downloading the image. But this is awesome. I am really pumped about the work. Shout out to the PNG working group participants. Shout out to Chris Bloom for writing this awesome summary so that I don't have to go dig into all the details myself. And thank you to you for watching as well. Let me know what you guys think. Am I too excited about this, or is it actually as cool as I think? Until next time, peace nerds.